Thank you, Christian. Next up, we have Noah Hunt talking about the landbird populations in American Samoa.
Good morning. I'm Noah from HCSU in partnership with USGS Pierce and the Pacific Islands Inventory and Monitoring Network, or PAC-N. I'm going to be sharing with you an update on the landbird populations of the National Park of American Samoa. This talk also represents the work of my co-authors, Seth Judge and Dr. Rick Camp. Nestled within the Samoan island chain, in the U.S. territory of American Samoa, lies the National Park of American Samoa on the islands of Tutuila, Ta'u, and Ofu. Not only does it preserve some of the most pristine rainforest in the Pacific Islands, it also hosts a diversity of species. It has the only paleotropical rainforest in the U.S. National Park system. And including among these species, the mamutangi, which is a critical seed disperser. Land birds serve pivotal roles as pollinators and seed dispersers, keeping these ecosystems intact. However, Samoa is also prone to intense episodic tropical cyclones, like Tropical Cyclone Gita in 2018, which, based on surveys that happened later that year, drove population declines in at least 2 species of birds. The National Park Service has an inventory and monitoring program. It includes 32 vital signs monitoring networks. The one in our region is the Pacific Island Network, or PAC-N, which monitors the conditions of key indicators of ecosystem health across the Pacific Islands, including the National Park of American Samoa, or NIPSA. And among those indicators of ecosystem health are land birds, which is why in 2011 they established bird surveys in the national park, and those were repeated in 2018 and 2023. So the information I'm giving you today is an update. We survey birds on the islands of Tutuila, which is the population center, and Ta'u, which is more rural. Birds are not surveyed on the mostly coastal unit of Ofu. Okay, we survey the birds through point transect distance sampling, which is based on surveyors from a fixed point detecting animals at the distances to that point. And the advantage of this framework is that it allows us to account for animals that we don't detect. However, there are limitations. So one of the assumptions is that the animal is not moving at the moment of detection. So some species like pe'apea are not able to be reliably surveyed in this way. We can't estimate population densities. So how do we go from distances of birds to densities? We build from the distribution of count data for each species. We have a distribution of distances, and we have 2 functions. There's a probability density function. This models the relative likelihood of a bird being present and being observed at that distance. There's, secondly, a detection function, which is the probability of being able to detect a bird at that distance. And these 2 are related. Let's see if this works. These 2 are related in that as you move out from a center point, your likelihood of encountering birds increases because there's more area. However, at a certain point, far away from the station, you're less likely to detect birds, which is why the probability density function rises and then falls, and your detection function starts high and then sinks low at further distances. Then we adjust our models based on various key functions, covariates, and adjustments to those key functions. We select the best one based on Akaike's information criterion, or AIC. We do bootstrap resampling to improve the estimation of our densities and also calculate our variance. And then after we use those bootstrap estimates of densities to calculate the abundance of the birds, we compare across populations for each year by each island with 2 sample z-tests, and that yields either an upward and inconclusive or a downward trend. I'm going to share comparisons between 2018 and 2023 for you all, but and up arrows are upward trends, down arrows downward, question marks inconclusive, X's, the bird's not present on that island. Just in summary, Fuya, Iao, and Mitivao on Ta'u had downward population trends. Lupe, Manutongi on Tutuila had upward, and Tiotala on Tutuila had downward trends. So if you haven't been to American Samoa and you doesn't make any sense because you don't know those birds, I'm going to introduce them really quickly. There's a lot of repetition between these slides though, so it's going to go a little bit fast. So first, Fuya. They're really important seed dispersers. They're also endemic to the Samoan island chain. However, unfortunately, we saw a nearly 2 bird per hectare downward difference on Ta'u between 2018 and 2023. Next were Iao. This is the most abundant forest bird. They were found at every station on both islands. And despite their abundance, they're also very important as pollinators. We saw more than 7 bird per hectare decrease between 2018 and 2023 on Ta'u. Lupe are another important frugivore dispersing seeds. Fortunately for this one, we saw an upward trend on Tutuila, which is encouraging because previously they had been heavily hunted and were impacted by tropical cyclones. Likewise, Manutongi was another case. We saw upward trends, and we're going to talk a little bit more about that in the discussion. Mitivao, a seed disperser with 2 subspecies endemic to American Samoa, had a sharp downward trend on Ta'u with over 4 birds per hectare decrease. Senga are pollinators and seed dispersers. We didn't see a difference in density. However, I believe this was attributed to the really high variance in those estimates. If you look at the population from 2018 versus 2023, it's less than half of the population. Senga Mo'u, important pollinators, showed no difference in their population densities between years. And then lastly, Tiotala. It's an omnivorous bird which eats a lot of insects, which is good. Unfortunately, there was a negative difference. This should say Tutuila, not Ta'u. That's a mistake. But there was a negative difference on Tutuila. And then we had insufficient detections of a few species. Manuma are a species of concern because they're very rare in American Samoa, and they're very dependent upon the fruits of figs. And then Moa, an introduced species. We didn't catch very many Senga olivao, which are insectivores and narrowly distributed on Ta'u, or Ve'a, which are also omnivorous and have very secretive habits. And then there are a couple species, Tu'aimeo and Vai, which do occur on Ta'u. A Tu'aimeo was detected in 2011, but not visually confirmed, and 3 Vai were detected on 2018 in Ta'u. So these birds haven't been seen in, at least 5 years, if not over a decade. Okay, so what's going on here? We've got a lot of downward trends. While we haven't confirmed the causes of these trends, the literature on island birds is becoming rich with examples of introduced rats, cats, and dogs causing population declines in birds. And we were seeing all 3 of these on the landscape. In addition, tropical cyclones do blow down trees, creating openings for incursions of invasive species. I was also seeing a lot of Myconia crenata on the landscape. And then they also reduce food resources by stripping trees of their flowers and fruits, and that disproportionately impacts pollinators and seed dispersers above other feeding guilds. So then what about Lupe and Manutongi? It seems like a relative success story. You need to know a little bit more about the history. Going back to the early 90s, these were nearly extirpated from tropical cyclones Ofa and Val until a hunting ban, and they were nearly over-harvested because they were seeking fruits in villages. However, a hunting ban in 1992 and then subsequently park protection in 1993 may have saved their populations from extirpation on Tutuila. And then we note that 2011 is, our first data point in this set, so there are limitations to that. However, despite the devastation of 2018 Tropical Cyclone Gita, we are seeing population increases, which is really exciting, suggesting that they're recovering and possibly rebounding. Okay, however, only 3 populations have returned to pre-Gita levels. The 2 Lupe populations on Ta'u and Tutuila, and then Senga Senga Ma'u, which has been demonstrated to utilize human landscapes, including agroforestry and village gardens. So they're probably more resilient when there's reduced food resources after a cyclone. Okay, in the future, it would be good to increase sampling frequency to more than once every 5 years. This improves trend analysis, it lowers those uncertainties, and it also allows us to detect early population declines requiring immediate management action. Also, we could research the effects of mammalian control and invasive plant removal on the bird populations, and we could also research limiting factors to Samoan birds relating to their diets. Whawhatai for everyone who's contributed to this project, and to you all for listening, and if we have any time, I would love to take questions or just take a snapshot of my email. Yes, Pat. I think I saw you first.
Were those birds that were declining also declining from 2011, 20?
Yeah, so, right. Pat's question was, were the birds that were declining also declining from 2011 to 2018? Every time we do this analysis, because we're feeding more data set into our models, we're getting just slightly different, not significantly different, but slightly different estimates. So for this report, we're only comparing against 2018. However, I do have population results from 2011. And the one that was really, there were 2 that were really concerning. I'm just gonna hit them real quick. One was Samoan starling. So it was having, on the 2018 report, it had a significant difference on Tutuila from previously, but not on Ta'u. You'll see that the confidence intervals are overlapping. The other one was the Senga, which, again, we're having issues with overlapping confidence intervals, which is decreasing our ability to actually detect a downward trend. However, in 2018, there was a downward trend from 2011. Does that answer your question, Pat? Those were the 2 big ones. I will add that every year as we get more data of birds, it improves our ability to detect trends. So in 2018 analysis, they were only able to detect 2 trends, and those were the ones that I mentioned just now. This is another reason why it's so important to sample more than every 5 years and have a longer data set, because that improves trend analysis. Yes?
You alluded to it towards the end, but you have multiple hypotheses about what's driving this aside from cyclone, habitat loss, etc. So has the USGS implemented monitoring for some of those biotic examples that you gave? Like, are they monitoring predators and their movement or abundance in the same landscape as the birds, or disease factors or anything? Is there concurrent monitoring for those species?
Yeah, so the question was whether USGS, or I'll add NIPSA, are monitoring for predators, disease, or other factors on the landscape. So currently, the only management-related actions that the park has been doing, and keep in mind that the park is like a very undersourced park. And they're very remote, so getting things to them is very difficult. The only management actions they've been doing is some invasive species removal, mostly along the trails where people are going and can spread them further. And they have been trapping mynas, but mynas, they're an invasive species also like here. There's not a lot of data to show that mynas are negatively impacting birds, and we didn't catch them on our counts. To my knowledge, however, there is no monitoring or predator control for cats, rats, or feral dogs. And feral dogs are probably the most noticeable in the landscape. So as a USGS affiliate, I'm not going to make any management recommendations, but if they wanted to study the effects of removing those things and see, just in case it might have a benefit, they could. Yes, Amanda.
Is your role for bioacoustics in monitoring these birds?
Yes, and you were in the acknowledgments, by the way. So Amanda helped us because I wanted to get VI detections. VI are the spotless crake, not detected since 2018. Extremely rare. Actually, they didn't have a Samoan name. It must have been lost until recently again because they're so cryptic and rare. I put song meters on Lata Summit, which is the tallest mountain of Ta'u, to try to get VI detections, and Amanda was helping me establish the perch model. Unfortunately, we didn't get any VI. We did get Ta'io, or the Tahiti storm petrel, which are an endangered seabird species. We don't do seabird populations for this surveys. But the answer is yes. Especially, here, or in Samoa, just like in Hawaii, there are really rare species that we don't know if they're extirpated or if they still could be out there. So the Tu'aimeo and the VI are two of those cases where bioacoustic monitoring would greatly help. And if we could send NIPSIS and song meters, I'm sure they would use them. Okay, thank you so much. Dr. Tyson.